In this video, we will work in Excel 365 online to understand and work with the binomial distribution. These are supplementary activities for an Intro to Statistics course where in Excel we do things that would be hard to do by hand, and students can practice and learn by doing these activities. This assignment uses the cloud-based online Excel, not the desktop version. For Bunker Hill students, this assignment is on Moodle for you, and for other people that might like a copy of this file, it's available by a link below the video. The purpose of this assignment is to understand the binomial probability distribution, which is a discrete probability model. Our objectives are to generate a binomial distribution in Excel because, unlike prior work, this distribution can be generated from theoretical parameters, and it sort of introduces us to the idea of like making models in statistics using theoretical assumptions and not necessarily having the empirical data on hand. We're going to graph a binomial distribution. We're going to calculate the mean, otherwise known as the expected value of it. And we're going to use binomial distributions to answer probability questions. First, let's generate a binomial distribution in Excel. To set up the distribution in Excel, you need two columns. Now, you don't actually need data to do this. What you need is a theoretical situation that meets the criteria of a binomial, having a discrete outcome, having a fixed number of trials, having no issues with dependent probability. And so we're generating this not based on data, but based on theoretical assumptions. So we make a first column that has the number of possible outcomes. This goes from 0 to the number of trials. The second column, we're going to use a formula, and we're going to calculate the probability of getting that number of outcomes in that number of trials. For example, getting 2 children that are girls out of 10 children. And we can generate this with the binom.dist function in Excel. Okay. So the binom.dist function is in red for you, and that takes in as parameters the number. This is your X value. Your trials is your number of trials. So if your number of trials is 10, this will be 10. And then this number goes from 0 to 10. Probability of success is what your probability of success is. So it's 0.5 if you're looking at the probability of getting a girl. If it's a die roll, it's a 1 in 6. And you can actually leave these probabilities as fractions. And then cumulative is always going to be set to false. So it's kind of an intimidating looking formula, but it's not too bad. And so, for example, if you have 10 trials and your probability of success is 0.5, your data column is your A column, and in cell B aside that, following along with this setup, you would use the binom.dist formula. It would take in column A, which in this case be the value from 0 to 10, and there'll be 10 rows, and then 10, and then 0.5, and then false. Okay, so let's illustrate how to do this in Excel. Okay, so I'm now in Excel in the assignment, which has a lot of tabs, as usual. The red tab will just be a copy of this video. The first section we're going to look at is how to generate our distribution. Then we're going to graph the distribution and look at the mean. We're going to use the same model for both of these and then answer probability questions. The blue tabs are the tabs I'm going to demonstrate, and then the yellow tabs are for student assignments to do. Okay. So let's generate a distribution for a theoretical situation. Suppose the probability of passing a class is 0.8. In other words, 80% of the students pass. And the class has 20 students. Generate a binomial distribution for this scenario. Now, in this case, we don't have actual data. We just have these parameters. And then this is actually the algebra model that will generate this distribution. In the old days, we had to do this all by hand. So let X be the number of students. That's our random variable. And then in our column besides this, we're going to have P of X, and that's going to be what we get from the binomial formula. Okay, so the number of students that pass specifically, that's what we're looking at. Right. It's a binomial situation because you either pass or fail a class. The number of students in the class is 20. It's entirely possible that no one passes. I don't know when that would actually happen, but I guess occasionally it does. And so the number of students that pass can be from 0 to 20. Okay. This I'm just doing a pull down to fill in. So this is our distribution. Our random variable can take the value from 0 to 20. All the students pass or none of the students pass. Next, we're going to do P of X. Now, P of X in this case, this is going to be what we calculate with this kind of big and ugly formula. So this formula here is the binom.dis formula, and we're going to use that. We're going to feed it in the parameters of, for each row, the number is going to go from 0 to 20. The number of trials is always going to be 20 because when we generate a binomial distribution, it's for a fixed number of trials. So if we had 20 students, it's one distribution. If we have 18 students, we do another distribution because that's a different situation. The probability of passing is given, and then cumulative is always going to be set to false. Okay, so this P of X column, I'm going to fill in using equals binom dot dist, and then there's 4 parameters. The first one is going to be flexible. This is going to be the one that's going to depend on the row, and it's going to be feeding it in the row value from here. Okay, so for E3, it's going to be, we're going to set the formula up first for E3 and then drag it down. The number of trials is going to be fixed. I'm just going to hard code that because we're not going to change it here. The next parameter is the probability of success. That's going to be 0.8 because in this case, we're modeling the probability of passing. We could also model the probability of failing, and then we'd have a different distribution, and that would be essentially the complement of this, but we're not going to do that. And then the final parameter, we're always going to set to false because we're not interested in cumulative probabilities, just for each row. And there you go. That's the setup for the formula. Okay. Once I set this up, I hit go and I'm done. Now you will get this E notation in Excel. This is times 10 to the negative 14th. This is scientific notation for like 0.00000, like really, really small. Effectively, when you see these E's, these are basically zeros. And so now that I have the formula set for that row, I'm going to pull it down very carefully. The little, it's called something, I don't know. It's a little button in the bottom right corner, and I pull it down and I get all of my probability values for each row. So this, for example, the probability of no students passing is basically non-existent for a probability of passing 0.1. So let's look at the probability of 10 students passing. So the probability of 10 students passing is 0.0002. So it's basically a really slim chance of that happening. The probability of 15 students passing is 17%, 16 students passing 21%, 17 students passing 20%. So you see that like the bulk of the number of students, not everyone passes, but the majority of students pass. There's kind of like too many decimals in here, so I'm going to take this, lasso it, right click, go to format, and just make it a little simpler. Maybe we want like 3 for this. 2 might not be enough because that might be a little bit too running. We definitely don't want to go to 1. Like that's not enough detail for probabilities. So I think probably like 3 is good for a binomial probability distribution. So that's the distribution itself. Okay. And once you have the distribution made, you can read off things. Again, this is made entirely based on the theoretical situation. And it's kind of cool to be able to get to the level of actually modeling things statistically. Okay. Okay, so now I'm back in the slides, and the next thing we're going to talk about is graphing it. I'm going to show you how to do this. It's really easy, but you just have to be careful and make sure that you're selecting the right thing. Okay, and on the same tab as graphs, we're going to calculate the mean of a binomial distribution, which is also the expected value. That we did in the previous assignment generically for a discrete probability distribution, but we're going to do it specifically for our binomial model here. Okay. This is, in this case, we're calling it the mean of the distribution, but it's the same thing as the expected value. This is, again, our x times p of x. It's just rewritten. It's the same exact thing as for the discrete distribution generically. Okay, so let's go in Excel and do that. I'm in Excel again, and that's actually my, when I do that, that's actually my my keystroke for stopping and starting the recording. Okay, anyways, so the next tab is graphing and finding a mean, just because to do them all in this tab was a little busy. So I'm going to actually select this, copy it, because I'm going to need this. I'm going to go into this graph and find mean, and then I'm going to do not paste, but I'm going to do paste special values only because we don't want the coding in. Actually, I'm going to reformat this too. Okay. So I'm going to right click and do format and go to number and go here. I don't want the binomial formulas necessarily carrying over. They can. I mean, you can do this on the same tab, but I don't want to do too much at once. Just because I'm feeling a little obsessive, I also want to move this over. Okay. So this is our model. This is our distribution model, and we have this all set for us. Okay. So now what I want to do is I want to graph this. Okay, because it says the distribution is generated. I want to graph it and find the mean. Now the expected value again was x times p of x. So it was this times this. So I can do this manually as this times this. And then I multiply these and I add them up. And then the sum of this is my expected value. This is from the previous assignment. How to do an expected value from the first one's not selected, but that's okay because it's 0 anyways. And so the expected value is 16. It just turns out this is that. That would be like on average, on average, that would answer the question, on average, how many students would pass the course? Okay. So on average, for this particular situation, if there's 20 students, 80% chance of passing, on average, 16 will pass. So the expected value in this case actually has like a lot of meaning to it. And that's kind of like an important metric. Like if you're doing like hospital, I actually wrote a paper a long time ago on like surge capacity in hospitals. You want to look at like the probability of like having so many patients in an emergency room on average. And that's how you do like your planning for staff and stuff. So there are like applications to this. Okay. So this, we don't actually really necessarily need all these interim calculators. We don't leave them there. The next thing we're going to do is graph this. Now watch. So in order to graph this, I actually just want to take the P of X column and I want to go to insert, and then I want to go to a bar chart basically and hit go. And then I actually get a nice graph of this. Okay. And so this is P of X and we can relabel. I always like a title on the graphs. I don't care if you do like a lot of other things, but titles. P of X is going to be the probability of n students passing. Okay. And so that's what we're looking at. It's the probability of, and then this is like the number of students, and then this is the probability. But the visualization, like this is the distribution in a table. The visualization gives you like a much better sense of like, so this is the number of students. It actually goes from, this would actually need to be relabeled. Oops. It goes from 1 to 21. It should go from 0 to 20, but that's okay for this purpose. But you can see on here, actually, we need to, yeah, no, we need to relabel this because it's bothering me. That's the horizontal axes. And what we want to do is set the min and max on this. It should let me. Display axes, vertical axes, legend, overlay, data. Anyways, I don't want to fiddle with that too much. Or maybe I do. Hang on. Okay, so this is actually a little tricky. It's inconsistent with the desktop version. So I'm actually going to redo the graph. So I'm going to go, again, I'm going to go to insert. I'm going to go to the bar chart. Now, in the desktop version, like it'll just give you a nice chart. Like you don't really have to like futz around with it too much. This one, however, if you just do like a regular bar chart, you get this, which is a little bit annoying. And it will default to doing this 1 to 21, which is what I want it to be 0 to 20. That was the issue. And so this one now, and then we also have this P of X column. We don't want that. So we want to format this. We do have these up here. I'm used to the desktop version, so this is making me a little crazy. But we go under chart format, we go to data. First, when we go to horizontal axes labels, we only want X. Students who pass. We don't want P of X. So that we just want this. And I have trouble like hitting, at least in mine, when I actually select it, it doesn't select, which I don't really know why that is. Um, so that's kind of really annoying. But I just did this like 3 seconds ago. So what I want to do actually is take this column. I want to get rid of this P of X. So let's just get rid of this. I don't want that there. Okay. So now it's correct. Somehow I made it. So now I have my 0 to 20. I also don't want this P of X there. Like I don't want this here at all. So just get rid of that. I want that on my vertical axes. And so I'm going to do this column values. That's the vertical axes. I'm going to get rid of this here. And it doesn't do anything, which it just did like 3 seconds ago. Um, partially because it's online and partially because it just doesn't like me. I want that. I want this and I don't want this. So I just want to delete this and it's not going to delete for me. Maybe if I just clear it out. I want that gone, but it's not going to let me. This is all like formatting stuff. This isn't going to help me. Primary vertical axes. That's not what I want. What I want to do, and I just did this like 2 minutes ago. Maybe if I refresh, it'll like reload. This is good though, because sometimes it's 365. I think this is why. So it's like stalling. Yeah, this may actually be my issue. So this might happen to you, so I'm going to leave it in. Okay, so let's try this again because I'm just trying to do select data and I want this to be students who pass. That's correct, but I want to get rid of this under columns. I don't want that. There we go. Bam. That was what I was trying to do. So I wasn't just doing it wrong. This is a nice histogram graph. Phew, I'm going to leave it orange because that's what I do. So this is our probability graph. I mean, I don't know why it was being, I think like my connection got kind of disconnected. This is one disadvantage of this online 365. Um, it will like have little hiccups. So it wouldn't let me, it had both the columns and for like column values and it was displaying like 0 to 25 here. So I had to basically fix this setup. So for horizontal axes labels, I have just my number of students who pass, which now goes from 0 to 20. Perfect. That's what I want. And then the probabilities are on here. And then each bar is illustrating the discrete probability. So for 0, there is no bar for 0. So you don't really start seeing bars till 11 or so. And that's because there's basically no probability density at any value below like 11. So there's really basically no chance that fewer than 10 students pass the course. I didn't touch anything. I literally did not touch anything. And it just did that. Um, okay, that's not what I wanted. Field, P of X. Okay. Now it's doing the opposite. Okay, so I got rid of that. There, bam, don't touch anything. And I hadn't touched anything. So this is actually the visual of the discrete distribution as a bar graph. And each along the x-axis is 0 to 20. That's the number of students that pass, and then the bars represent the probability density. So finally, we have like a really nice one. You could edit this, but I'm having enough issues with it just as it is. But anyways, it's much easier if you can get the graph to work nicely to actually look at the visualization than the table. The table shows the same information. And then also in the visualization, you can see where the number of students that pass, which we could relabel it. It's always good to label things. But you can see the density where, in most cases between like 14 and 18 students are going to pass. It's kind of unusual for all 20 to pass, unfortunately. And you can actually see the visualization of the binomial distribution graphed out. You can also see the expected value of 16 is the biggest bar. That makes sense now that on average 16 out of 20 students would pass. Okay, so that's expected value and a graph of the expected value distribution. It's a discrete distribution, so it's a nice bar chart. Um, and that's a good solution to looking at the binomial model. Again, this is a model, so like if you're doing professional work, this is actually a nice way to look at, like, possibly the number of failures in a batch, or the number of patients in emergency room beds, number of students passing certain exams and stuff. So it is kind of like a practical thing to know how to use the binomial. Okay. I'm back in the slides, and the final thing we're going to do is just answer some probability questions with a binomial distribution. So once you have the distribution set up, you can answer all kinds of questions. Now, again, this is a theoretical distribution, so it's like a what if kind of situation. Um, and you can use this to do modeling of things and predictions and planning and things like that. So it is kind of cool. Okay. So let's go back in Excel, and we're going to go to this last tab that says answer probability questions. And this is, I used to have chickens, so this is kind of a interesting little situation, and it's actually based on fact. So suppose the probability of a chicken laying an egg in one day is 0.7. So for a 30-day month, let's model how many eggs the chicken's going to lay. So X is going to go from 0 to 30, and there's not quite 30 rows, so I actually want to like stretch my knowledge of things and do like a I want to do a zoom view out, but it's not going to let me because it's interesting. Okay. So I'm going to do 0 to 30, but I have to actually like go down a little too, because yeah. I don't want to do that either. Oh, here we go. Okay, so I'm going to do zoom, and I want to do something close to 100 because I have 28 rows visible, but okay, that should work. It's going to be a little small, but it will work. So I'm going to go down here and 20. Let's make this a little bigger, like 90, I think will work. I don't know, I'm playing games here. Okay. So that should fly. Okay. So we have our X column, and then we also want our P of X. So this is going to be using that binomial distribution formula. So P of X. Now what I'm going to do is I'm going to use that formula again. So this is going to be equals binom.dist. Right, this formula looks really intimidating, but once you use it a couple times, it's like, hey, that's kind of easy. And I do like to introduce a few things in intro stats that are a little bit sort of like more sophisticated MBA type things. So our first, and we have 4 parameters. The first one is just going to be whatever's in X. That goes from 0 to the number of trials. Number of trials is 30 because that's 30-day month. This probability of success is 0.7, which is the probability chicken lays an egg. And then cumulative is always going to be set to false for this. Okay. So that's all we have to do is set the formula up once. We get our first probability value, which again is pretty close to 0 because realistically, if there's a 70% probability a chicken lays an egg in 30 days, it's extremely unlikely the chicken's never going to lay an egg unless it's sick or like the middle of winter or something. So then we can pull down this formula very nicely. And then what it's doing is it's automatically filling in like every single row with the same formula, which is great. Again, I'm going to reformat this just because this formatting just kind of like makes me crazy. And I'm going to make it like number, and then we'll again use 3 decimal places because we really do need a little bit of detail, but not too much. There we go. So now we have our complete binomial probability distribution where X is the number of eggs laid. Oh, sorry. Wait a minute. Wait. I didn't pull this down to 30. I only pulled it down to 20. That's why it was a little short. I got to go to 30. Oops. I don't want to do that because I'm going to mess things up if I do that. Okay. Let's hope this works. You might not be able to see the tab on the bottom anymore, but that's okay. You don't really need that. Probably should choose smaller distributions for teaching purposes. So I'm going to do a fill series. Yeah, so now I have 30, and I also want to pull this down. There was nothing actually wrong with these. I just didn't do a complete 30-day. Okay. So there we go. And we have our complete binomial distribution filled in. Now I could graph this, which would be really interesting, but it's a little difficult to graph these, or at least I thought it was. You can make a nice graph of this, and it would be a better way to visualize this. But my aim here is to answer some probability questions, which are on the left. So the questions are, the probability chicken lays exactly 28 eggs rather. So all I have to do to answer that literally is just look at the 28 row. So that's like really easy. The discrete random variable is equal to 28, and the value of that is 0.002. So, I mean, that's not super high, but chickens don't necessarily lay eggs like every single day. They come pretty close. So, like 70%, I think, is exactly, it depends a little on the breed and the age of the chicken, but that's pretty close to like accuracy. So, all you need to do is just copy this value there. Again, the probability they lay exactly 20 eggs, that would be the 0.142. So that would give you a good idea. I mean, there's a 14% probability that basically 20 days out of 30 the chicken would lay an egg, and that makes sense given that 20 out of 30 is like 66% and like 70% is like the probability. So that's a good guess. But now we have like compound probability questions. The probability chicken lays at least 20 eggs. Now this one, to do at least 20 eggs, okay. Um at least we do have format painter in the online version, except it doesn't seem to be working. um when you're running the online version, like things are not local, so it's like it's a little more difficult, and I'm messing up my formatting again. Um, it doesn't like, it has a little hiccups and it doesn't like run super smoothly. At least for me, it doesn't. I don't know if it's my internet access. Okay. But so problem C and D and E are now like compound probabilities. The probability the chicken lays at least 20 eggs. This is actually going to be at least 20 means 20 or more. So this is going to be the sum of this because mutually exclusive events, the probability of A or B, you add them. So we're looking at the probability of 20 or 30, or I mean 20 or 21 or 22 or 23 or 24 or 25. So it's going to be the sum of at least 20 is 20 inclusive, and it's going to be the sum of these guys. And so that's going to be 73%. So that's, reasonably at least 20 eggs you're going to get for a month. Okay. The probability chicken lays between 10 and 25. Again, that's going to be equals, and then the sum. And this would be equivalent to like writing the probability of 10 or 11 or 12 or 13, and like you could write it all out on paper and look at this in an intro stats class. But the probability of between 10 and 25, now I'm doing it inclusive, including the 10 and 25. And so that's going to be 97%. So you're basically like, I mean, you're pretty certain that the chicken's going to be somewhere in there. The probability chicken lays less than 10 eggs. That is going to be the sum of 0 to 9. Okay, less than 10 doesn't include 10. So I'm going to do this, and then I'm going to do the sum of 0 to 9. And that's going to have to be really, really super small. So it's basically non-existent if your chicken's like laying eggs. Okay. And so that is like how, like, once you have the binomial distribution like all set up in Excel, it's good. Now we could also do the expected value of this, or in the case of the binomial, that's also n times p. So the expected value would actually be 0.7 times 30 or 21. And you could actually see that like that's the highest value in the discrete distribution. Okay. So again, I have done the 3 blue tabs, and there are 3 yellow tabs for the students to figure out and then turn in. Okay, thanks.